Hi, hello everyone, and welcome back to my YouTube channel Spotify Learn. Today I'm here with the video of from today I'm concepting more about the first is about the blueprint that is focused of mathematics of second PUC. First we will discuss what is the overview of the blueprint for the upcoming examination. Next we will discuss the first chapter, that is relation and functions. MCQ, all type of questions will be covered. You can see the whole video and you can understand the concepts very clearly. First let's see the blueprint. Okay, as we can see here, first is relation and function. It is having 9 marks, that is one MCQ, that is it may be either fill in the blanks or MCQ type questions. And next is one 3 mark and one 7 mark, and the whole chapters I have given here. For trigonometric, inverse trigonometric, it is 6 marks, matrices is 9 marks, and determinants 12, and continuity and differentiability is 17. Applicatives of derivatives, that means applications of this, is about 8. Integral is having the highest, that is 18, and application of integrals is 5. Differential equation is 8. Vector algebra is 8. 3D, that is three dimensional geometry, is 6, and linear programming is 6, and probability is 8. You can see where it is marked for 3 mark and all. I'll cover most of all the concepts. I have planned as once I'll upload 1 mark questions, all the possible 1 mark questions. Next I'll be uploading for 3 mark question. Next video will be of relation and functions, same chapter, 3 mark questions. And next we will see about the 5 mark question, how to solve stepwise and all, it will be explained. So do watch the video completely to get the idea about it. Now let's start with the MCQ. Okay, I hope you have seen the blueprint. Now let's start with the MCQ. The first question, we will understand the basic concept of that particular question and then solve the question. Okay, first what they have given, a relation R in a set A is A. Okay, set A they have been given. If each element of A is related to every element of A, then R is called. See, they have given each element of A is related to A. That means what it is? It is a universal function relation. Okay, if a particular element it is related to particular element of that only, it is called to be universal. And now next question they have given is both empty relation and the universal relation are. That means you call that as trivial. You have to remember this. If it is empty, that means if it is empty and it is universal. See, here we saw about the universal, right? If it is empty and universal, we call it as trivial. You have to remember this particular word. Next question is, let A be the set of all students of a boys hostel, then the relation R in A is given by R is equal to A comma B, that is A sister of B, that they have given. See, we can understand that in the boys hostel no students can be a sister, that means no ordered pair. That means it is what? Empty relation. See, you can understand it, they have given it is a boys hostel, no one can be the girls. That is the logic behind this question. That means no, that means it is 0. 0 means what? Null. Null we call it as what? Empty relation. This is the answer for the particular third question. Next is about the a relation R in set A is called reflexive. Reflexive means what? A comma A, that means the same element of the particular element should be belonging to the particular itself. That means it should be related to for that only. Okay, that means the option is answer A comma A. That means here they have given for at least, and here some implies, here some implies, so these cannot be the answer. And this can be answered because they have given A comma A. Reflexive means this. And next we will be discussing about the symmetric, transitive and all. You can understand all those concepts. See, they have given a relation R in the set 1 2 3. They have given by 1 1 2 2 3 3 1 2 2 1 1 3. Okay, now let's discuss whether it is reflexive, symmetric and transitive. See, first reflexive, as we studied here, A comma A, that means the same element. Here 1 comma 1 is there. Okay, 2 comma 2 is there, and 3 comma 3 is also there. Now let's see for symmetric. Okay, for symmetric to answer, this is about reflexive. For symmetric, let's see, that means if 1 2 be there, 2 1 should be there, 1 3 is there, 1 3 is there, but 3 1 is not there. You can observe here, this is not there, this is there, okay, and this is not there, so it is not symmetric. Okay, now for transitive, you can take transitive, that means 1 1 if it is there, and you consider another, that is 1 2 2 2. 1 2 is not there, okay, sorry, 1 2 is also here, okay, 1 2 is also there, this is agreeing. If you take 2 2 and 3 3 2 3, okay, this is what 2 3 should be transitive, that means first element of this and last element of this should be belonging to there. 2 comma 3 is not there, so you can say that it is reflexive but neither transitive nor symmetric. Now let's see the sixth question, that is a relation R in the set A 1 2 3 is given 1 2 and 2 1. 1 2 and 2 1 means what? It is symmetric but not transitive, that means 1 1 is not belonging here. 1, why? If you answer 1 1 is not belonging to the relation, you can say the answer. Now let's see the seventh question, that is 1 2 3, and you have given 1 2 2 1 and 1 1. See, 1 2 2 1, that means 1 1 1 1 is also it is transitive, and 1 2 2 1, that means it is what? Symmetric. It is both symmetric and transitive, so the answer is option C. Next question you can see here, that is eighth question. Okay, let R be the relation in the set 1 2 3 4 given by the relation they have given. What is the correct answer that we have to choose? Okay, see, 1 2 is there, 2 1 is not there, okay, 2 1 is not there, so it is not what? Symmetric. Okay, now you can see 1 1 is there, 2 2 is not there, 2 2 is also there, 3 3 is also there, 4 4 is also there, so you can say it is reflexive. For transitive, you can take any two relation, that is 1 2 and 1 1 means 1 1 is there, 2 1 and 2 2, 2 2 is also there, and 1 2 2 2 1 2 is also there or not. 1 2 is also here, you can see. Now next is about the 2 1 and 2 2 2 3, and see, you can take, see, to disprove that 2 1 and 3 3 you can take. 2 3 should be there for transitive, 2 3 should be there, you can see here 2 3 is nowhere. Okay, so you can say it is not transitive. You should search for option that it is not symmetric, not transitive, but reflexive. It is reflexive, it is reflexive and symmetric. No, sorry. Yeah, it is symmetric. Answer is option A. Next, if you see about the ninth question, that is, sorry, here, yeah, see, you can see here, it is transitive, right? All A is present, it is reflexive, and it is reflexive and transitive, but it does not hold for symmetric. So the answer is option B. You can cancel all these three. Now, next is about the ninth question. Let R be the relation in the set n is equal to, R is equal to, they have given a relation as, you can see what the relation they have given, A is equal to B minus 2 is the relation they have given. See, now next they have given a condition, that is B should be greater than 6. Okay, you consider some value for B, that is greater than 6. You can do 8 minus 2, that means what? Answer is 6. That means answer is option 6 comma 8, like that you can take. You can take any value that is greater than 6 for B and you will get the particular answer. Okay, if you take the B value as 6, you will get the answer as, if you take, consider A and B if you take 8, A you will get it as 6. So the answer is option 6 comma 8. Next is about the 10th question, that is, consider the non-empty set consisting of children in a family and a relation R defined as A R B. If A is brother of B, then R is. See, they have given a non-empty set, that means it is having some elements, that is children in a family and a relation R that I have given. A is a brother of B they have given. See, to see that it is neither symmetric nor transitive, but because brother relation is neither symmetric nor transitive. Okay, if you take some A set and A B set and B C set, A C is not belonging, so it is not transitive. And similarly, AB means BH cannot be belonging, so it is not symmetric also. Next question, you can see if the relation R is 1 to 3 and R is defined by 1 2 means what it is. You can see only they have given what 1 2. So it is none of this. It is not reflexive also because 1 1 2 2 and all it's not there. It is not transitive. You cannot consider only 2 sets also. To similarly for transitive 1 2 means 2 1 is not there. Okay, for symmetric. So the answer is option D. Easily you can say this. Next question is, let L denote the set of all straight lines in a plane. Let a relation be defined as particular if and if only L is perpendicular. See, L is, they have given perpendicular to what? M. Okay. Now for that answer, the answer will be symmetric. That means if some particular A, B will be, you consider some, see they have given L, M, right? That means M and L will also be belonging to that. It will be belonging. But L and L will not be belonging. So it is not reflexive, not transitive. It is only symmetric. Next is you can remember as perpendicular function. That means perpendicular function is only symmetric. Next, sorry for the interruption. Next we will discuss about the 13th question. They have given R is the relation that is set of, that means 1 2 3 4 they have given, and some relation 2 2 1 1 4 4 and 3 3. Now we have to say whether it is transitive, reflexive or symmetric. Most of the question they will repeat from this only. See, you can see for reflexive all they are having particular set. If you take these two, it is reflexive. Okay, you can see the answer is reflexive. First let's see what are the sets they have given. 2 2 1 1 4 4 and 3 3. They all are what belonging to, that means A comma A. It is in the form of this, right? That means what A comma A belonging to R means it is of reflexive type. That means you can say that it is having, that it is confirmed as reflexive because they have given only set is 1 2 and 3 and 4, right? So all the three, that is 1 2 3 and 4, all the four are having itself particular. So you can say that it is, answer is the, it is reflexive. If you take A B B A, that means it is also in R, and every pair of that belongs to, that means it will hold automatically. If the particular function is reflexive means this all are in the set what they have given to 1 2 3 and 4, all are having reflexive means it is called to be equivalence relation. That means it is reflexive, transitive and symmetric, all the three. I hope you understood. The idea is that equivalence means that it is symmetric, reflexive and transitive, all the three. As it is holding reflexive first only, you can observe that it is having all the three, that is called as reflexive. And reflexive will automatically hold that. Now let's discuss about the 14th question, that this they have given. Let W denote the words in English dictionary. They have given a particular relation, the word X and Y having at least one letter in common. They have given what, one letter is common. That means every word is there, it will be shared with itself. See, if you take A, it will be shared with itself. That means it is having A and X and Y. If you take X and X, Y and Y, it will be having one letter in common. Okay, so that is answer. It is reflexive and symmetric. Okay, a and A, if it is there, what, A and A again should be there. That means it is the reverse. Symmetric is nothing but reverse, right? If you take AB, it should be BA, but here it is AA, so AB, A again. So it is reflexive and symmetric, but it is not transitive. Now if you take the set 1 2 3, the number of equivalence relation containing 1 2. See, to find out equivalence relation, the answer is option 2. Equivalence relation numbers. They are asking set is equal to 1 2 and 3 is the set they have given. Now if you have number of elements, that is 1 and 2, that means answer is option 2. Okay, now next they have asked is about, see they have here said as 1 2. Here see they have given 1 2 and 2 1, but the set is containing is same 1 2 and 3. Now you can say that answer is option D, that is see 1 2 2 1, that means it is answer is option 3. 1 2 and 2 1. Three equivalence relations satisfy the condition. Let S is equal to 1 to 3, the number of relation containing 1 2 1 3, which are reflexive but not symmetric, and symmetric but not transitive. See, they are asking you have a set and how many number of relations can be having 1 2 and 1 3. That means it should satisfy the condition reflexive, it should satisfy symmetric, but it should not be transitive. Okay, now it should not be transitive means you can say it can be 1 2 and 2 1, that means it is symmetric. 1 2 and 1 3 they have given means 1 1, it is reflexive. And if you want 1 2 and 1 3, that means 1 3 should not be there, it should be, it will be transitive. So they are saying it is not transitive. If you take 1 2 and 2 1, it is symmetric. 1 2 1 3, it is 1 1 1 3. Okay, 1 3 it will be transitive, and 1 1 and 2 2 3 3 will be reflexive. So the answer is option 3, that is 1 2 and 3. Next is 18th question. They have given if set 1 1, that means you can observe the by the this relation only, it is having reflexive, right? It is reflexive. See, if you take 1 1 and if you take the self and 1 1 only will be there, so it is sorry, reflexive, right? This is reflexive. Reflexive is not in the option, but it will be symmetric and transitive. 1 1 and 1 1, if you take again 1 1, it will be belonging to R only. Okay, now if you take the 19th question, that means they have given n, that is natural numbers defined by relation n divides m they have given. Okay, now then R will be what? It is divisibility, right? The logic here is divisibility, so it will be reflexive, transitive, but it will not be symmetric. Next is T is the set of triangles, Euclidean plane and all. Now you have B and A, and B belongs to A, that means it is congruent appliance. See, now you can see it is congruence of triangles, right? It is an equivalence relation. Equivalence means what? As I said, it is all three condition. Okay, now next is 21st question. A is equal to 2 3 4 5, B is some relation they have given, that it is a factor of from A to B, then the range R is the set. Okay, now what they have said is elements of B divisible by some element of A. Okay, elements of B, that means you can see 36. 36 is divisible by what? You can check for 36. To check is 36 is 9, it is divisible by 3. 45, 45 is divisible by 5. 49 is divisible by again 3 also. 60, 60 is divisible by 3, and 77 is divisible by 90 is divisible by 2. That means it is some divisibility test. Okay, so now you can see that it is divisible by A, that means 36, 45, 60 and 90. See, for 77 I didn't say any divisibility because it is a not divisible by any number, it is a prime number. Okay, it is prime. Okay, next all are divisible. This is divisible by what? 3. Again this 9, it is also divisible by 3. 60 is divisible by 2 as well as 3. 90 is also divisible by 3 as well as 2 as well as 5. Again so many it will be divisible. I have said just examples, but 77 it's not divisible, so you can say it as a odd one out. Now the number of relation for equivalence relation in set A 1 2 3, that means they have given 1 2 3. Okay, now the elements of 3, that means it will be answer is option C. Oh sorry, they have asked maximum, they have not asked number of, okay, they have asked maximum number of, that means it is answer is option 5. That means for bell number of 3 elements will be equal to 5. This is the logic behind this 22nd question. Now they have given A or B, that is A greater than or equal to B. If it is greater than or equal to B, that means you can remove 1, 2 and you can make it equivalence. Okay, you should remove 1, 2 because A is less than or equal to B in this condition. You should remove this. Then you can make it as equivalence. Okay, now you can say that answer is option equivalence. That means reflexive, transitive but not symmetric, because 1 2 is not there, no. So if you remove this it will be equivalence. If not, you can say this is answer is option B. 24, that is a relation they have given, and see the 1 1 2 2 3 3, okay, and 1 2 1 2 is there, what it should be removed. They have asked in order to make it equivalence it should be removed, means if you remove this it will be reflexive, what, so you can make it by removing 1 comma 2, you can make it equivalence here also. Next is 25th question, that is let A is equal to 1 2 3. See, 1 1 is there, 2 2 is there, 1 2 2 3 and 3 3 is there. It is reflexive. 1 1 is there, 2 2 is there and 3 3 is there, but not symmetric because 1 2 is there and 2 1 is not there, because 1 2 is there, 1 2 is there, 2 1 is not there in relation. So it is said to be answer is option A. Next is about the 26th question. Is that again 1 2 and 2 2 they have given. The answer should be it is reflexive, but it is not symmetric. Again here they have not given about the reflexivity is not there. So now you can see the answer, it is symmetric and transitive. You can see, observe in the previous which question we discussed also the same logic was there. Again this next type of question came, that is about the f is equal to f of x is equal to x power 4. They have given x belongs to R. Okay, now they have given function and we have to say whether it is 1 1 or on 2 or many to 1. Many to 1 means you can have two sets, means it should be belonging to one only particularly. 1 to 1 means it should be having unique. 1 to many means 1 to many. Okay, that means this is the logic. Now you can say x power 4, it's not 1 1 not on 2, because plus or it is not 1 1 not on 2, where is the answer is option D. Okay, it is not 1 1 nor on 2 means it should not be plus or minus, and no negatives should not be there, so that it is not negative and plus or minus, so it is not 1 1 not on 2. You can take f of x is equal to 3x. Okay, now this is 1 1 and on 2. Okay, see, you can take 1 1 and on 2. For on 2 you can take f of x, that means you can take something as y, and f of y you can consider as 3x, that will be equal to 3y. That is also belonging to the relation. You can say it is 1 2 on 2, and if you substitute the value of x as to be 3, and 3 into 1 it will be 3, 3 into 2 it will be what, 6, and you can relate that. Okay, 3 6, and if you take 1 it will be 3, and if you take 2 it will be 6, if you take 3 it will be 9. The same way you can have 1 to 1. Okay, it's not 1 is connected to 1 6 and all, so it is said to be 1 1. Now if you take x power 3, there we had x power 4, here it is x power 3. X power 3 is 1 1 and on 2. That means if you can substitute f of x is equal to x power 3, you can substitute f of x to be y is equal to x power 3, and it will be equal to y power 3, and it is also belonging to the relation, and you can substitute any value for the x is equal to 1 2 3 etc., and you will get the same answer. Now you can see the next question, 30th question. f of x they have given what? F of x they have given as 1 divided by x, right? Now for the f of x, it is not defined. See, for not defined, for which means x is equal to 0. See, f of x is equal to 0 means 1 divided by 0, it's not defined yet. You can say it as infinity. We generally say it to be infinity, but it is not defined, right? So you can say it as not defined. Answer is option D. For 31 question, see, f of x is equal to 2x plus 6, which is a bijective mapping. Okay, bijective mapping. I have uploaded the video of this chapter fully for understanding of bijective, reflexive, symmetric and all. You can watch that video also. Then f inverse of x, that is f inverse of x is given by what? Now you can see it as 2x plus 6 is the they have given. Now if you take x minus 6, it will be divided by 2, right? That will be what? 2 ones and 2 threes. That means x minus 3. The answer is option A. Next is 32. If A set contains 5 elements and B have 5 here, sorry, 5 here and 6 here, then the number of 1 1 and onto mapping here. For this formula, it is, see, no bijection, because it is having modulus of a is not equal to modulus of b. If you consider this a and this as b, it is not equal, so you can say it as answer is option C. Next is a, that is a set is given 1 to n, b set is given ab. Now we have to find the number of surjection. Surjection is what? You have the formula 2 power n minus 2. Okay, that means 2 power n minus 2 is the formula for surjection. Next is 34th question. Set A 5, again set B 6. Next the number of 1 1 to onto mapping will be here. See, 6 permutation 5. That means I hope you know the formula to find out the permutation. That means 6p5. Okay. Now it will be having 6 factorial divided by 6 minus 5 whole factorial, that will be equal to 6 into 5 into 4 into 3 into 2 into 1, that will be equal to 720. So the answer is option A. Now 35th question. A element contains 5 and 6 elements, then the onto mapping, you have 1 1 we studied. Now for onto you have to say it as 2n plus 3 is injective. Okay, injective, but it's not surjective. It's what? Not surjective. So the answer will be option B, 120. 2n plus 3. Now next is, when a modulus is less than b, we say it as, C, a is less than b, right? So we say it as onto. The answer is option C. Okay. Now for the 36th question, 2n, sorry, this question I wrote, I guess. 2n plus 3 is called what? Injective, but not surjective. It is what? Injective, but not surjective. 37th. Z to Z, they have given the relation. What are the bijections that we have to see? See, for the bijections, you can say that x square plus 1, except this all can be there. For answer is option A, B, C. If they give the here, maybe some mistake have happened. If they give answer is all three, that is A, B, C, this will be the answer. And if they give this D is not the answer, except that all are there. Next is 38th question. They have given 3x minus 4. You have to find out the invertible. That means f inverse of x. You can see that means you have x, this as it is invertible, you may convert the sign and divided by 3 will be there. X plus 4 divided by 3. Answer is option A. Next is s is equal to abc set given, t is equal to 1 2 3. Now you have to find out function from s to t. Okay, f inverse exists. Now you have to see means a to 3, b to 2 and c to 1. This is how you have to find out the s, as they have given s to t and it is f inverse. You have to invert in the order of first and last element. So the answer is option A. Next, 40th question, they have given set is equal to 1, 2, 3, 4, and you have to find out the number of 1, 1 function. To find out the 1, 1 function, it is 4 factorial, that is number of relation factorial, it is 4 factorial, it is 24. The answer is option C only. This is the video of MCQ of first chapter of relations and functions chapter. Next, I'll be uploading a 3-mark question for the same chapter. For that, make sure to like, share, comment, and subscribe to my YouTube channel. If you find this video helpful, you can let me know. And if you find the video helpful, or if you have any doubts which I have explained, you can let me know in the comment box. I'll clarify it for sure. Thank you for watching the video. Please stay tuned for the upcoming videos. If you have not subscribed and watching the video, make sure to subscribe and then watch. Thank you.